Okay, so the first thing, it's extremely used extensively in financial data analysis space. Okay, generate fixed frequency dates and time spans. Okay, time series maps. I mean, you can play around with non-standard time series. You have different time series from different locations, right? You can play around with that. Let's see what is it bringing to the table. Okay, so let's see here. So what we have here, we have a range object, right? We are using pd.date range, mentioning the starting date, mentioning the periods and the frequency. So what does it do? From this date, it will generate 72 periods of frequency r. I mean the time we're taking into hour, right? So we have 2011 110, adding 1 hour, adding 1 hour. Got it, right? So you add 1 hour, and how many times? 72 days. Right, 72 times. Right. Okay. So where, I mean, it's, I was wondering where you can see like what are different options could be like in the if you what you can do is to see different options. If frequency equal to just to help PD date range. Sure, right. It will show you different values corresponding to PD date range. Got it, right? If you do that, you'll get what are the possible options it takes. Okay, and so on. Okay, so similarly, right, previous date time series okay, so this was a date, this was a date time index, right, which is already generated. You can use it as an index value. Okay, you can use it as an index value. Index is equal to range. The previous date time objects, because of that, what happens? What is your date? I mean, this is the data np arrange 72. So if you do this, this becomes your index. So date time actually became your index here, right? The previous data we stored in the range object. We stored in RNG. Okay. RNG, and then we gave that as index to this data frame. Right. Okay, data equal to np.arrange of 72. Right. 0 to 70. So it's a series. Okay. Okay, so let's see further. Okay, so we have I mean, if you want to convert that information into frequency distribution here, like what you're doing, the same data time series that we have earlier, right? You are converting time series as frequency 45 minutes. Right, so what you're doing here, the same data, that this was 1 hour, this was second hour, and all that, right? You can see here, this is, yeah, so it will be same data. Okay, this will be same data. This 0 to 1, you're mapping 0 here, 1 to 2, it is 45, as you can see here, and so on. Right, so similarly 1:30 it will be 1, 2:15 it will be 2, 3 o'clock it will be 3, 3:45 it will be 3. Right. What is pad? I mean, method is equal to padding. That means the way it is filling the value, right? Okay, you are using padding. Padding means copying the previous data here. How are you filling this information? Okay, so similarly, if you want to do sample the data based on date, right? As you can see, this base is the object of time series, right? No, sorry, not the normal series. Yeah, D is an object of normal series. The only difference here, the index is a time series. Index is a time column. So that is what makes a time series. Index is time, right? So that is what makes a time series. So we need to do time series. Yeah. No.
How TS is nothing but we just created this data series, right? See this. This is what we did, right? TS is equal to PD.
Okay, yeah. Time series is more like concept rather than function or model. What is D here? Capital D.
Capital D is date here. Date.
Okay.
Date, right? So what you're doing, you're resampling the data and it creates a group by object sort of a thing. Okay, so what you're doing here, you're doing, right? Remember group by, so it is grouping it based on date, and you can see this date, this is the information. So you don't have to write a lot of these code actually. It automatically will do these information things for you.
I didn't get this one.
So the above.
Can you print the output of D?
Which one?
Small d. What is?
Right? So you can resample. It is returning you this object. Right? It is like a group by object. It is, see, in the above case, you are creating 72 hours, right? 72 hours means 3 days. 1, 2, 3. Okay, so you are grouping it based on this. Okay, so if you do, you have all these options here. Got it, right? Then see, Python also provides you an internal datetime object like this from datetime import datetime. Okay, from datetime import datetime. So once the datetime object is datetime function is there, you can pass here month, year, month, date, and hour. It can create a datetime object. And once you have the datetime object, you can use the timestamp function to create a timestamp out of it. Right? You are creating a timestamp out of this. Okay. Now, okay. So let's see further. So then you have pd.timestamp. So what is pd.timestamp? You have this value. This is your year, month, date. You're writing a string, but it is creating a timestamp object. So understood what is a final object? Timestamp is a final object here. Right. Similarly, you have a timestamp. This is how you can create this. Right. Different ways to create it.
So we could have executed step 17 as well directly. I mean, there is no need to first execute step 12.
No, absolutely not. You can directly execute. There's nothing. Okay. Then sometimes you need to pass between this and this period what happened. Right. So what you can do is pd period, and this is this time here. Okay. So what it is doing, it is creating a period here. 2011 January, and what is the period month? Here you're mentioning date. This is 1 day, and this is date. Then period 2014. So of course it adds a December field over. So what is it doing? It's creating a period out of from the information. Right, period from the information.
Sorry, question on number 12 and 18. So what is the why we are using date time there?
So earlier was a string. So for sometimes logs you'll see date time in string format. Right.
This is 12. If you see 12, we are given 2012, 5, 112, right? So there we use datetime function first. Whereas in 18, we directly.
So this is what means is you're using Python datetime utility to convert into Pandas timestamp.
Okay.
Okay. Python datetime utility. So this is you're doing it directly.
Okay.
Okay. Two ways of doing it. Okay, so there are other ways to create a timestamp. This is what is important here. This is what you use. Like you can write in this format. You can write in this format. Okay, so what you're doing, you're creating a, you're creating a list of timestamps. Got it, right? You're creating a list of timestamps here. Okay, and that list you're passing it as an index here. PD series. Here, this is the value. This is the dates. So the time series, this is the time series again that got created here. Okay. Oh, this is very important. So see the formats in which you have dates coming here. You can see this July 31st, 2009. Then you have November 22, 1985. Okay, 2005, 11/22. Okay, 2005, 11/22. So you have your PD series and you have all this information here. Okay, so PD.to date time. Okay, so what is PD.to date time doing here? It is actually converting date in any format, right? You can see different string formats here. You can see comma separated values. Okay, comma separated values. You can see this format and this format. It is converting all of them into standardized date time format.
If you are if a single one, like only one format, like by space or only for like July.
That is also fine.
Then we need to remove PD.series.
Huh? No. Here just to date time. It is actually taking a series of date which is in different format. Okay, and it is returning a date time of Pandas date time.
Oh, it is taking different format, but it is giving the output in the standard way.
Right. No, there are no fixed formats. Okay, there are no fixed formats. That's what I was about to show you. You can see here to date time. You can mention here the format that you are getting the time. Just imagine you are reading a CSV file. You are getting date time object as a string. So you have to convert that into standardized format so that you can write queries. Basically, if you have the index column as time stamp, right, you can write what happened in month January's, what happened in month whatever in this particular year. You can write queries like that. You don't have to extract string strip and all that. You don't have to do all those things. You can directly write queries.
Output is always in the same format. This one.
Output
month and
right. Output is in the same format. Yes, you can apply PD.to date time to data frame. Actually, you will apply it to data frame column. Right, your date time will be one column, isn't it? So you'll be applying PD.to date time data frame dot column name. That is the series that we are playing around with, isn't it?
Because when usually we read data from text files.
Right. See here, to date time, and it is taking entire series and it is giving you output. Got it, right? This is similar to passing a column.
And then in place equal to 2 or something, you can replace the.
Yeah, can replace the absolutely. So many times you need to generate date time stamp. Right. So this is what you do. You have start date, you have end date. Okay, so you have start date, you have end date. Okay, and you can mention the frequency. So start date, end date, and the frequency. So you can see a start date and the frequency is 12 hour. Got it, right? So it will generate date time separated by 12 hour every time. Clear? Understood, right? Specifying end is not mandatory. If you don't specify end, you have to give periods, as you can see here, which will tell you how much frequency, how many times you're generating the data. Okay, so B date is something not so common. This is business days. The start date, end date, you are generating business days. So it will find you non-Saturday, Sundays, and generate the stuff for you. Only business days. You can also mention holidays. Okay. You can also mention holidays here, as you can see. Okay, so here you can see weekend mask, holidays.
Week mask, Monday, Wednesday, Friday. Holidays.
Gangadhar, is there any question?
No, Antik, sorry.
Oh,
No.
okay.
Yeah.
Okay. So here, as you can see here, you have this holidays over here. Okay, and this holidays is the list you can configure here, right? So it will generate date except these dates. There was some issue in the earlier releases. I think now it is fine. You can check with your new release. Got it, right? So B date, range, start, end, frequency, week, mask, which week's day you want to mask. Okay, here I have written Monday, Wednesday, Friday, right? And this is not working. There was some issue in the older releases. I think now it is fixed. Okay, and you can mention which holidays you don't want to generate. Got it, right? So you get information about those dates.
What is equal to B?
It was for business days actually.
Oh,
okay. So here is all the meanings. So if you right, these are all the meanings. B is business, day frequency. Okay, all the meanings are here. Okay, so let's take a case. Suppose okay, suppose you have a data frame which looks like this. 3 column of data randomly initialized. Okay, so here you have
frequency as seconds.
Yeah, here frequency as seconds, and you see the second number 0, second number 1, second number 2. It's generating the date time. See, date range, you're generating data by seconds. Okay, after that, if you do DEF resample T2, T3T, what does it mean? It will actually combine data by hour, 3 hour T. Okay, 3T means 3 hours. Okay, if you want to see the mapping, yeah, this T means minutely frequency, H is hourly frequency, 3 minute, huh? Didn't see it? Oh yeah, it was minute, right?
Yes,
minute. Sorry, hour was the first one. Okay, so this is the documentation which talks about what is what. Okay, you're calculating mean of every. So let's say you are getting second wise information, then you're calculating sample 3T mean. So it will give what happened in last 3 minutes. Got it, right? What happened in last 3 minutes.
And if we do this resample, it means some data will be lost, right?
No. It will create an aggregation. So it's a resample R, you're doing a resample. After that aggregation, NP sum and NP mean you're doing. Okay, so it will calculate sum and mean of the data. It's not that it will leave any data. It will calculate whatever data is coming in the 3 minutes, right? It will calculate sum and mean of the data. Okay. Okay, now I had some data with me. Okay, which is like Roseman sales data. So here you can see here you have, if I just load the data, huh? Okay, if first thing I should be doing info to see. Okay, so you can see here date information is it, since it is extracting from text, it is actually treating it as object, right? It does not really understand that this is date. So what you have to do here is, as you guys are saying, you are, of course, you are doing sales date is equal to PD2 date time sales date, and after this, if I do
Date time.
understood? Okay, so now it is a date time object. So now you can expect it to behave differently. Okay, what you can do is you can make this date time object as index. So that is what set index date time object. So you do this. Okay, once you have this, okay, if you do sales, you'll get see the data in this format, right? You're seeing all that. So suppose you want all the data for 2015, right? You're getting all the data. You want data of, see your which all month you have, 7/1, right? You want all the data of, understood? Why you need time series here? See all the January data only you get.
But this is the only date, not the time. Because if we have to resample it to the R, then we cannot do it.
Can do that.
Because R's are not mentioned, right? Only date is mentioned.
On this particular data, only
For
date
this
is
particular data. Depends upon the database whether they are having the complete data.
Just one question.
Yeah.
So if the date format is in the number format like 2015-0131 without any delimiter or something, will it how will it consider that one?
Without any
Do we
delimiter.
need to specify? Yeah, without any delimiter, like without space or something, like 2015-0131.
Mm-hmm.
Then will it consider that, or
For
will throw
that,
any error?
no. For that, when you are doing to date time, right, you have to pass that utility formatting. Remember, I discussed about format. Here, here you format. See the format to date time format. So you have to pass the format like this.
Okay. Okay.
But the format also, it will change the format of a date. Will it change the format for a number? Suppose if it's a number 2017-05 and 31, and it's a complete number, so will it change?
I mean, 31 means
date.
Oh, 025 and all that. No, it will first treat, I mean, take it as a number, then you have to convert it as a string, then you have to write a splitter which will do that.
Directly.
No, I mean you can do that. I mean, in the format you have to do that. I mean, first it has to take it as a string, right? Then only it will understand it. Number it won't directly understand. Okay. Similarly, let me show more things. So here you have, right? So you have now data. The sales data is based on this time series now, right? Right. So what you can do, you can join two data based on this particular date, isn't it? Right. You can play around with it. So this was, things that you resample and head. Head will show the first. What will head do? Head will show the small part of the data frame, the first size sample of the data frame. Okay, and resample will actually reorganize the data based on whatever parameter you're mentioning here. See, in this case, resample 3 minutes. This is the actual data. So it will combine all the data in 3 minutes and it will give one representation of it. And you will calculate sum of it, mean of it for this column, mean of it, sum of it, and mean of it in another column. Right?
Sir, once again say about the 3T.
3T means 3 minutes. Not error, 3 minutes. So you'll group all the data. This is the previous one. Here you see, right? Here you are actually, okay, here you are grouping all the data that has come in first 3 seconds. Yeah, first
Okay.
3 minutes. Then you are combining this and getting this result. This is mean of it, first 3 minutes data for this.
Okay.
Yeah.
Okay.
Okay, so we'll solve a small problem using time series also. Okay, but
One second. So here in 56 line we are doing the mean of that first 3 minutes, right? In 58 also we are using the numpy mean. So does it make difference?
yeah, here it is like this is more generic. Here it is specific. That means you'll do mean only. Here you are.
Yeah, but here if we use only mean without, I mean, instead of sum or aggregate function, if we use simply np dot mean, both will be same, right?
Right, both will be same.
Okay.
Okay, and I'm sure a few more things.
Right, you'll see the last function standard deviation.
Okay. Why didn't, isn't there anything called np dot standard deviation?
There is.
Why we
you can write your own function also.
Okay, that.
Yeah, so whatever is there, right? I mean, you need some aggregation function, so you're writing your own function. You can do, you can write f and do the aggregation over there. Same thing, same. I mean, the fundamentals remain the same.
Can we rename that also? I mean, it's showing
Lambda.
some
Yeah. You can rename everything. I'll show. Okay, so
no.
okay, so that's because you have you have two layers, right? Here, this first layer is A, next layer is B. Suppose you want to get only A columns. How do you do that? Right, you are getting A columns. Suppose right, you are getting all the A columns. Now suppose you want to get you're getting lambda columns. All you have to do is change this guy, right?
Can
Okay.
you change the column name?
Yeah, column names we can. I mean, I'll show it another example as well. But if you have to change column names, you will do this.
Suffix,
Rename.
suffix.
But that is add a suffix, add something to the column name, suffix to column name. You have this rename variable, columns. You give the key and value, whatever you want to change and what you want to change. Okay. I'll show this using when I'm doing this other example. Few more things to show there. Okay, so we discussed yesterday string operations, str dot, right? And this. So after this, I mean, we'll do some data analysis on the data using visualization techniques. Okay, I mean, we'll now get into visualization. Okay, so let's see. Okay, first understand, what is data visualization. Data visualization is supposed to give you a brief summary of the data. It is supposed to give, there are three popular libraries of visualization. One is your Matplotlib, the other one is your Seaborn, the third one is Bokeh. Okay, Bokeh is an alternative to your Tableau. Tableau is paid. Okay, Bokeh is free. Okay, Bokeh is an alternative. So yeah, the foundation library that we will be discussing here is Matplotlib. Okay, Matplotlib. And Seaborn is another library. Okay, which is little advanced than your Matplotlib. Okay. So so there are two. So how do you import this Matplotlib? Import Matplotlib but pyplot as PLT. Okay. Then you have percentage Matplotlib space inline. What does it mean? Your whatever graphs it will generated, it will show in the notebook itself. That is the second line about. This line percentage Matplotlib inline. This will plot the graph in the notebook itself. Fine, right? So.
One thing on questions. Why do you data visualize with the help of this library?
Yeah, so data visualization actually gives us some brief understanding or insight about the data, from how data is distributed. Some information about the data you will get from the on-bit visualization.
There is also different tools, but why we prefer this?
It's not that we prefer Matplotlib. You have Seaborn, which is pretty popular. The reason why we discuss Matplotlib is foundational. If you understand Matplotlib, the other things will be a piece of cake.
Show results in the form of
graphs. Yeah. So why do you need that? You need because data to speak, right? If you see a lot of big organization, they will do a lot of analysis. Finally, they will give you simple graphs. By seeing that itself, you will understand that this is what is happening. So it needs a lot of skills to develop a simple output. Right? Complex output getting is difficult. because you can put a lot of information.
It will directly show the numbers and it is very difficult.
Right.
It will be more easy to one question. So here we are using Jupyter notebook, right? But in real world, I mean, if we need to use
You'll save this graph as JPG file.
oh, we can save those.
Save this, yeah. Okay, and you can save it in a location where a server will pick that up and show it to the customers.
Or on the web page, we can.
Right.
These libraries have the option to save.
Yeah.
So data visualization means the same thing. Means we are showing that output in the form of graph. That is how we are
Visualization. Yeah. So I'll use one you can do is one from Pandas from Matplotlib. You can do pass the data. You can do the plotting from data itself. You can plot directly, but both of them using Matplotlib. Okay, so what I'll show now is I'll from the data from series from data frame we are plotting data directly. Okay.
So we are just importing a module from PyPlot. We don't have to.
Yeah, I don't have. This is as import. Okay, now see this what we have done here. We are creating a series of 1000 data, and index is from this particular date. You are generating 1000 information.
What is this inline? Inline.
The inline thing is to plot the graph here itself. You don't have to, the notebook itself.
If you will not, like, if you will exclude that notebook,
then the graph won't show up here. You have to call the function plot plt.show. Like every time you want to show the graph. Dot show. Okay. Otherwise, by default, as soon as the object is created, we start showing up.
This thing will only work in this notebook. But if anybody is working in some
then this slide will not work other than this. So in that case, you'll do plt.save like this a.gh, which will save an image in the current directory with a.gh. Fine. Okay. Okay, so let's see the series. So you have 1000 data here, right? The series means one column you are plotting. Remember this, one column. You have 1000 series and index information is your date. How many dates? 1000 dates. See here. Okay, of course. Okay, P8. If you have this is a series that gets generated and you plot this graph here. So yeah, it generated it. And if you see, it created a file also a.jpg in the directory. In the same directory, this guy. Okay, so you whatever. Okay, you can put, so you can do data analysis, create a graph, add it to your mail, create a graph, put it in your web application, it will show the analysis. Also, you can make it dynamic also. Just change the data, it will generate the graph, it will show it to you. Okay, if you want to create dashboards, and you know what is dashboard? Right? You can do in the back end, there can be a lot of data, but your dashboard will show what is the current state of it.
A lot of sets are there. A lot of sets we combine to show their movements at one
place, right? Dashboard, right?
Multiple graphs or multiple reports in one place.
Okay. Now let's see.
In that TS equal to p.series, you have written np.a 1000. So that 1000 and periods equal to 1000, that should be seen, right?
Right. So because x-axis and y-axis. So this index becomes your x-axis.
For each value you have
and each value becomes y-axis. Value becomes y-axis. Understood? So from the series, this is the series. Remember, plt. So either you can do series name dot plot. You can do this also. Series name dot plot. Right? Or you can do plot plt dot plot and pass series to that. Understood the difference? First one is you have created a series and you're calling a plot function. Okay. Second one is we are passing a series to the plot function.
So how it decides what to take in x-axis and what to take in y? Is it like by default index?
By default, index will be x-axis and the value will be y-axis. This is in case of series. But as you expect, things will change when it is data frame. Data frame has multiple series, right? So, and of course, one index. So, index will be x-axis, multiple series data will be different lines, right? Pretty much this is what you expect, right? And this is what it is. You see, we have 4 columns.
Okay, for each 4 different.
Yeah, so you need a df dot
Comes
cumulative sum, right? So it is each column, it is actually adding those values and creating a cumulative sum, right? And then you are plotting the df dot plot dot line. You see 4 columns are represented in 4 different colors here. So just imagine 4 columns: 2001, 2002, 2003, 2004. Different.
Can you make a different graph over here?
Hmm?
Can you show into different?
Of course, you can. So you can show x-axis and in the series you mentioned, but that particular column.
Dot. Instead of line, you have to mention what.
Right. Say in this case, here I'll show it in the line below. So this is all the columns, right? Sometimes you need only this is the column names you are mentioning. This is the column now, right? df3. So you want B column and you are adding one more column here, A column. Fine. Okay. So what you want A column to be behaving as x-axis and B and C as y-axis. This is what you're saying. Right. See, A column behaved as x-axis. Okay. Of course, you can make you can make index also as x-axis. Okay. Then B and C column as y-axis. This is 2 different columns.
And if I need to make it as a bar chart or something, is it possible?
Of course. We'll see that. Understood, right? What this guy did? Okay. So anything in the line and all, you can use this plot function. Suppose, okay, these are the other type of plotting: bar, histogram, box plot, okay, KD, area, hexabin, pi. Different type of plots.
Why are you using histogram?
Histogram is to show frequency distribution. What is frequency distribution? You want to find out what is the distribution of data, right? Okay, just a second. Okay, let's see this now. Okay, so we have all these things: bars, histogram, box plot, KDE, area, scatter, hexabin, pi. Okay, let's take one by one. Say we have this data frame like this here. I'll discuss about histograms and other things. Okay, so I mean, maybe if you
something I stuck like it's showing it's I already done like input pandas as PD. After that I'm doing that PD dot series function. T is equal to be defined. Then it is showing PD is not defined.
S capital.
Series.
Yes.
So yeah, the common mistakes, right? So I know what
I
you
was searching where it is.
Yeah.
No, PD is not
input.
defined.
Yeah. So let's see now. So we have these 4 columns which has all this data. Now what I'm doing is I'm picking up one row out of it. iloc will give you one row, right? And you are calling that plot function after that. You have one row, and when you do iloc, what do you get? You get a series, right? Series. iloc it will get you data frame or series. So let me just. Index, but just take me data.
Full rows. It gives us the data frame, but whatever frame.
So this is it. Okay, this is your head. Okay, now if you do ilog, just simply ilog. Yeah, fifth row it will get, but what is that object? This is the series.
Okay.
Okay, so whenever you have series, you can plot this bar graph. Okay, but you're plotting what type of data you're plotting? Bar graph. So these all values you're plotting in a bar graph. So where it is minus 1.3, it will be down, plus 4.5 above. Right? So you can see minus whatever value is and other values. This is all. Huh? Then yeah, you can do that. But remember, the data has time as
Log is based on value.
Value.
Your ilog is based on series, right?
Index. Yeah. And it is returning one series. That's it. So if you have to change it into log, first you have to change the date. 200. So you can see this is date you are giving. It is showing for that date this was the status.
So you can get series as well.
Got it, right? So series you need, and whatever the value is there in the series, it will plot in the bar graph.
If you want to display the value in the bar graph, is it possible?
Can do that.
The label.
Label, X label, Y label. So the thing is, okay, I may not finish all this last stage fine tuning, but essential thing you should know is everything is possible. Okay, everything is. It might be look into documentation, might be a person to search into Google, but as this is very flexible library, it is used widely for many applications. Okay, so almost everything you should be able to do it. Okay, I haven't come across. Maybe you know it, you don't know it. Okay, forget it.
Using this library can be integrated with some other visualization tool.
Why would you integrate a visualizing tool with some other visualization tool?
Which I mean to say, not this one. Exactly, machine learning really covered or Python.
Is there any machine learning here? No, you just have the data and you're just connecting data. It's absolutely can. Okay, let's see further. Okay. So any data, it has nothing to do with this. So any data you can convert into data frame or a list also. You can pass to this, it will work. Okay. Then you have bar plot. So you have 10 rows with 4 columns, and when you do plot bar, okay, remember, okay, 4 columns means at every point I have 4 values, A, B, C, D, right? Plot bar. So that's what we see here.
Suppose I want to make it, please make it like 0.0 to 1.0 as a pure 100%. That stack bar graph, I want to make it that. How it is possible? Stack bar graph. Stack means it is showing 100%. In the 100%, it will divide how many it will be there. Yeah, this one.
Yeah. So everything will come, just be little fiction so that I can go through. Okay, all the things will be there. Okay, just a little patient. Well, I'll have to jump, right? Yeah. So let's see what is happening. So everything is possible. Okay, I mean the essential, that is the story. We might skip a few things, but everything is possible. So let's see what happens over here. You have df2.plot.bar, right? So what you are doing over here for each day, right? You have 4 information, right? It will plot it at 4 graph. You can think about product sales, right? This sort of information you will use in, okay, I have 4 stores of mine, and you can see every day what is the, and you can get a, this is the pattern of it. It gives a really good, this is a very useful plotting technique actually. Okay, then you have
there is log plot, sir. Semilog plot.
Semilog plot, right. You can do that as well.
Okay.
Okay, so here you have this df2 plot bar. This is stacked option, right? It still shows you the summary, the same thing that you're asking, right? How do you combine this? And all the cases you have that stacked is equal to true field. If you pass that, okay, if you pass that, you will convert that. Okay, if you pass that, you will convert the data into the stacked format. All the things you have here, bar stacked. Then you have the option of, okay, this guy, a bar h horizontal. right? It also gives you a lot of idea about what is happening around. Then you have histograms.
Okay, will give bar H or bar P for vertical or horizontal?
V you don't have to give.
Only bar is
Bar.
default. We will take that.
Yeah. Okay, then you have this histograms here. Okay, so what is histograms? Histograms actually shows you distribution of information. Then in this case, what you have, it's again a series over here. Okay, you have only one particular column A. So when you do that df3 plot histogram, it is telling you what are the values of the particular series getting distributed here, right? We can see here a lot of data are between 0 and 1, 0.5 to 1.5, right? Lot of data. Okay, and very less data. This is a normal distribution of data. That is what it is, right? Normal distribution.
But in ML, whether this one is preferable, most preferable, or
No, yeah, I mean,
is fine.
no, it's not about what is preferable. You know, what suits the data most. What is the best way to understand the data?
Yes.
Right. That is how you decide what is the best way. So if you basically want, today we are doing a data analysis using attacks. What type of attack is there? There are various types of network attacks. So we plotted this histogram and it showed that okay, this particular we plotted actually bar graph. So we plotted bar graph and plotted okay, this particular attacks, this is the frequency, and this is the number of times this particular attack was happening. Okay, so depending on the data. Okay, just as of now, just understand these are the tools. Actually, when we start doing machine learning, then we'll be using a lot of this plotting.
This is what I am teaching now upon this visualization in Pandas. This is ML or it is before that?
Before ML.
Or something.
Before ML.
What is it?
Visualization.
I sort of all our topic is under number because only I think one or two classes.
Oh, okay. No, it's different. After Pandas it starts. So here what you have is a data frame. Okay, in the data frame you have column A, column B, and column C. These are the three columns over here, and of course you can see we're generating some different random data. The important point here to note is this is the data frame here. You're mentioning this alpha is equal to 0.2. This alpha parameter tells you how transparent will the histogram be. If I make it 1, it will be very dark. You can't see what is behind it. So many times your graphs overlap, right? If you want that overlap information to be obtained, like you can see here, all the graphs overlapped here. That is why this color is coming. Okay, so you can see this color. This is your C graph. This is your this graph. This is your this graph. Okay, so if you make alpha is equal to lesser value, say in this case. Okay.
It's difficult.
Right, if I make it 1, you'll not see the background stuff in it. Okay. Similarly, you can do stacked is equal to this. If you do stacking is equal to true, it will build on top of it. Right? Previous day sales, today's sale, and all that. If you combine all the results, you can get things like this. Okay.
If I want to create few data visualizations with the help of this Python matplotlib, so how we need to integrate, how we need to show to somebody else, like other tool, there is a studio, there is a server we are doing that. Where in the desktop we are doing some visualizations and we are deploying it in the server. But here, how to?
Here also you do the same. So
server is just there.
Yeah, so I'll show it during the final stages of deployment, right? Okay, so then I'll show it. Okay, so then we have horizontal graph, right? That's pretty much. Okay, then you can actually have, that is known as subplotting. Subplotting means plotting multiple graphs. So I'll give you some examples. So you have you want to plot you have 6 features and 1 target. You want to plot corresponding to each column what is the relationship with the target. Okay, you can use subplotting over there. Right. Subplotting. So what it does is this, if you do diff, it creates, okay, And df diff, if you do df, what is your df? Right. Right. If you do df diff, it gets data like this, right?
Yeah. 4 columns.
Yeah.
So the dual axis data plotting is possible. Dual axis, like it is negative and positive. Suppose my data contains.
We did that, right? First one. Bar graph. I mean, it actually doesn't matter. As you can see, this is very generic APIs, right? It really doesn't matter what you're trying to do. All you have to figure out what is the best way. Like, so here you saw that you had 4 columns. So this is one column. It is plotting. This is another column. This is another column. Histogram. So it actually created 4 graphs out of this.
So first thing is bin equal to 50. So is it like 50 part?
Yeah. So what will you divide it? See, you can see here
50 blocks.
So here, right. So here you have bins 20. It means the buckets in which you are dividing the data into. By default, it is 10. But if you want to reduce the bucket size means from minus, if you make the bin is equal to 40, earlier case it was -4 to minus say 3.75. It will again divide by 2. Okay, it is just taking the number of buckets that you're dividing the data into. That's it. Okay, it's the
number. Come down the red graph again. Here, graph number C, we have a minus 2.5 as mid for some partition, whereas in other graph or A and B we have minus 5 to 5. So, is it because the data of C is more granular or?
No, I mean all the data is anyway randomly generated of normal distribution. Like, so when you do this, I mean, it will be this also.
Randomly generated, but it depends on the value.
Yeah, so if I do this. Right, this is your normal distribution data. If I do diff, it means difference from the previous value. I mean, it was a. So if you do see all this DF histogram as of now, as we understand, it takes only 1 column. Okay, if we do this, it will generate you 1 graph only. Right? Got it, right? Yeah, so now all you're doing for entire data frames, it will plot for entire thing. That's it. You don't have to write a loop and all that. You don't have to. Understood, right?
What
diff is actually, the previous value to subtract from this guy, df. Okay, that's your first value was NA and all that. So let me, show some separate code for something. I'll load some. Okay, so I'm loading some. Oh, sorry, pandas I didn't import pandas are speeding. Okay, now okay, this is your employee data, as you can see here. This is your employee data. We want to see all the columns. Okay, you can see this column number is wrong actually. There is one column name with sales. Okay. If you do here, you can see this is actually a department. Got it, right? We have to rename this column. Okay, we have to change the, sales column name to department column. This is department, sales, IT, all those things. Okay. So what will I do? Data dot rename. Okay. Columns. Sales to department. Okay, so it has now changed it. Fine. Yeah, it will reflect in the same.
So it changed in only the data frame, not in the actual file. If we need to update, we need to write it
back. Yeah. Now suppose you have to plot things here. Okay, so you see here a few things. First is you want to understand which department people leave the most. Got it, right? This is, I'll tell you about the data. This left column that you see here, right? This is means people who left the organization. Okay.
So group by.
Yeah, employee data group by, right. And then what will you write? You want to group by based on left.
Okay.
Group by based on left.
No, group by based on department, and then sum of.
Yeah, I mean group by based on left. If you do, you'll get all the values in that particular. You can do both the ways actually. So if you do group by left, okay, and okay, this will give you group by object. Then you. Okay, so you can see in the entire data, these are the people who didn't leave. These are the people who actually left. Right? I mean, there is the first information you are getting. Okay, then, okay, what you basically need here, you basically need, more information, a lot of information here now. Okay, you first you need is, okay, what is the distribution of department of number of people? What is the distribution of department? Got it, right? Group by department.
The count, I mean, we just need the count of number.
Size, right?
Okay.
Okay, we get that. So here you can see this is the, remember what is this here? This is the series here, isn't it? This is the column name and this. Okay. So what you can write, I'll show few of them remains assignment with you all. Employee data distribution department. So how I need to plot it? What will be my x-axis? X-axis will be department, right? And here it should be the value. So what type of plotting will I be doing here? Bar graph, right? Yeah. So what will I do? Right, and you have the information here quickly that sales, there are a lot of people, right? That's how simple it can be, right? Okay.
And one more thing, if I want to calculate something means I have to say calculate in any column values. I have to compare. I have to do, suppose it is in Excel, lookup of the 3 6, its value will be equal. Then I have to calculate based upon the code, like some code like no. If it is maths in the row column, then we'll take this value. It is possible.
Yeah. Whatever. See, now the question is, how will I do it? The answer to is it possible? Yes. Whatever comes to your mind, if you think that is logically connected, the answer is it is possible, right? Because it's that popular library. How you do it, that can be a good question. Got it? How you do it? I mean, how you do it? Okay. So let's try a few more things, and so you can note down a few questions here. So this is a good data set for plotting here. If okay, next question is okay. If I mean, I'll show a few other tools, but okay. So if you have to find out of course, if you have the you have to plot average monthly hours for each department. Monthly hours for each department. How will you do that? Average monthly hours for each department. Okay, let's see this. Okay.
Average monthly hours.
Can you take the average of all months? That's how many hours they spend for all months.
And P mean for the entire column, right? This is group by department. Then on doing group by department, which is the column that you're interested in?
Average monthly.
What is the name of the column?
Average underscore monthly underscore hours.
Yeah. Right. This is average monthly hours. Okay. And basically, what do you feel like doing it? You feel like sorting it, right? Sort values ascending, right? You'll see that increasing. So, and this is the data you want to plot in data. Okay. It's pretty much same, isn't it? But yeah, technical people are more involved in work, slightly more compared to others, right? Fine.
There was not much difference in the average.
Not much difference. In fact, we saw it. So that's okay. Everybody works hard, right? Okay.
I plan to prepare one report like this.
Oh,
actually for the employee, we're charging the barcode for all hours, every 8 hours. How much they engaged and like 50% the utilizations, how much they have already. How many? Suppose I have 50 employees. 50 like how many they are doing the performance kind of things. Like 8 hours. After 8 hours, how many hours they are working.
Okay. So people will hate you if you do this, right?
No, the director gave.
Huh?
Director only gave.
Oh, I thought if you do this, people.
No,
but anyway, let's come back.
You want to see in monthly, you want dashboard, you want to see weekly basis.
Weekly basis, right? This is something.
Then he'll catch up the person and give the task.
In this graph, maybe is it possible to modify axis or something like?
Yeah, you can do.
Because
everything.
it's not visible, right? I mean, zoom in kind of.
This information. So by default, yeah, I'll show it. So what you can do is PLT dot. I mean, if you want more control, this is one simple way. It will do auto correction of a lot of things.
Okay.
Okay. That if you want other way, PLT like plot bar. Okay.
Height. Which is almost argument
height. Yeah. So. Wait, let me see the. Okay, so if you use the R way, you always have to pass little more parameters. Okay. Right. Here you'll see it will tell you. I'm doing a bar graph, right? You can see here sequence of scalar heights. Oh, heights of the right. Now I remember. Okay, here it should be a vector actually, heights. So sequence of scalars. Okay, so what is the this is a series, right? Index. Values. What is it containing? Yeah, just the value.
Index is
yeah, let me just okay, so employee data R. Okay, so you have this was showing us index, right? I was passing it an index. I have to pass it as a list actually.
Oh, okay.
So you have to take care of all these aspects if you're plotting from. Understood, right? There are two ways. One is you do it from like data frame itself, which is very useful, which is what I always do, which I will always recommend, because you don't have to take care of all these details, right? Now when you're using from, you need more control, right? More operations, more control. Then you can use this way where you are passing PLT, right? So in this case, okay, I just need to see some log. Okay, PLT dot bar. Okay, this is your X data. Okay. It shows a problem.
I will do go
With the same thing?
Yeah. Two lists and then divide it by values.
You have to mention height is equal to.
This is little okay, but it should have worked.
It's working for me.
Should have worked. It's working for somebody here. The error is not very explicit also.
PLT dot bar, that's it, right? And then two lists.
Oh, we might not have imported as the right library. PLT, no, things are fine.
We already ran separately, right? These two.
Yeah, technically it should have worked. So let's check what is there. But anyway, I mean, this is how we will use it mostly is for you. It has worked, right? Yeah, it should have worked. Yeah. Yeah, so here we have somebody whose things are working. So just you can check it out what is wrong. Okay. Yeah. Let's see further. Okay. So similarly, we can do a lot of visualizations of this data set. Okay. So play around with it and prefer to use this way. You'll always find it very simple to do. You don't have to, and it will automatically align things for you. You don't have to actually. If you use the other way, right, you might have to provide which alignment you have to do, what are the x-axis, y-axis. It needs more control. But if you're using from data, it will figure it out the best way it can. Okay, let's proceed.
Sir, how can we represent the data in the index in horizontal way? Now I get it lot. Okay. I'm not asking about these bars. I'm asking about the names in this index. Is IT, RAND, D. They are coming horizontally now. How can we get that?
It's already horizontal, right? How can you get that in a sense?
No, in the above diagram,
No, in above diagram, if you get it horizontally, it will overlap actually. So that is why what it has done automatically, it has converted it into, if you got it right, if you get it like this, it will overlap. It will not be readable. Management.
Okay, but in my diagram, it was in horizontal. How can we convert in vertical then?
If you are using this way, it should be horizontal. I mean, it should be like this.
But if we are using that bar.
Last line, you have write that last line, no sir. For that, I got the plot, but the values are overlapping.
Exactly. If you do execute this code, it should work. I am little wondering why.
It was working out, but the values here are in horizontal way.
For that, what you have to do, you have to do this plt dot y label. Got it right? You have this thing y label, x label. There you might have to pass more arguments here to do this.
Okay.
Okay. There you have to pass the horizontal direction, alignment. You can pass. So this needs this. Will give
Instead of bar, we have to write y label.
Y label, right? I mean, after this, you have to configure this. Then you know. Okay. Oh, and that is label. Then you have x ticks. Whatever you see these values, right? This is your x ticks.
Okay.
Okay. X ticks is your the one which shows here. This one. Okay. So if you want to configure that, you want to pass the alignments, you press tab. Sorry. Okay, you pass the tab here. Okay. You can pass a few parameters here, x ticks. It will control what are the that comes on the x-axis. Okay. So either do this all manually by yourself, which is this is the old school way of doing it. But if you want to do it comfortably and more or less, this guy works pretty well. I mean, I don't have to go mostly for that. Okay, this works well. Okay. Yeah. Okay, that's why I have all the entire library written this way. Now the next important thing is box plot. Okay, this is a very interesting piece of observation actually. Why this is important? It helps you understand the distribution of data. Okay, for example, you have this particular column here A. It tells you the lowest data in the particular column is point something like this, 0.1 something, and the highest data is 0.9 something.
We call them outliers.
Outliers. Yes, it's a very good observation to understand the data right out, and you can see the middle 50% of the data is here. So you can see the data is very unevenly distributed. Okay, it's quite spread out. Similarly, see this column, you have highest data here, lowest color data, and 50% of data here itself. This is a good distribution.
What is the box? So inside the box, the data is
50%. Okay. This is the green line is mean of it. This is the 25% of the data. This is 75% of the data. Okay. This is your plot.box.
Then B is C B. B.
B.
In the box plot, no? In that B, one more column. Yeah, B. It means it will be 25 and 75. That one.
Yeah, you can see here described, right? You see 25% here. B column, it's 25% is 0.167. So this value is 0.167. 75% is 0.70. This value is highest value is okay. 75. Yeah, this is 0.70. Okay, the highest value is max. Right. If you do describe, it will just, it is a visual presentation of describe here. That's it. Green line is a mean of it. Okay, so box plot. Okay, then you have this area plot. Area plot is this is like more of a time stocks data. This is what you will do actually. Area plot. What it will do, it will plot the. It is like default. It is stacking on top of one another. This is yesterday's sales. This is today's sale, and the difference between them shows you what was the difference in the sales from yesterday and today. Okay, then you see the green data. You can see very less difference here in the first column, right? When you see very less difference in the first column, what you see over here is very less sale happened here on the day 1. On the day 2, quite a bit of sale happened. On the day 4, quite a bit of sale happened. Understood, right? So similarly, if you mention stacked is equal to false, as you expect, everything will start from 0. It will not start from where the other guy ends, right? That is when stacked is equal to false. Okay.
Sometimes whether we call it dual axis.
Yeah, everything you can do dual axis. Okay, I mean dual axis is not something which is very explicited. It's by default everything. It's just matter of data, what data is there. Okay, it gets the information from the data. Okay, then you have this scatter plot. Okay, scatter plot is, this is what you'll do. Like for example, you have this is one information, this is another information, and both the information are continuous in nature. It will typically plot the relationship. So let me try to frame a question over here. Okay, so you want to find the relationship between satisfaction level and average monthly hours, right? How do you do that? Satisfaction level and average monthly hours.
Scatter plot. X-axis, Y-axis.
Right. So data. Plot scatter. X is equal to what is that column name?
Column name satisfaction and school level.
Yeah.
Where you got this data?
Is there in the, everybody got the data from GitHub, right? Yeah, it's there in GitHub. Yeah.
Will you upload this document today?
Yeah, I'll upload this one as well. Can you see this? Okay, but as you can see, it's really a lot of information over here. So what you can do, you can get a sample of it, if not everything, to understand the observation. But yes, people who have, okay, you can see a lot of data in this bracket, isn't it? Right, so we can, this information anyway gets very difficult to understand, isn't it? So what you can do is you can plot a hexa. What is that? Hexa plot. Hexa.
Data is all over.
Yeah. So you do this plot hexa bin. To understand the, because if a scatter plot does not work great if it is a lot of data, huh? Hexa bin. Okay. So you can see this and some more, and you can actually configure the bin size here. Grid size, yeah, grid size. Grid size, say 25. Can you see this? This is the pattern. Okay, so what it tells you that this is a little high denser area. So one thing for sure, this is strange, right? People who put lot of hours sometimes have very less satisfaction level. A very important observation here. Did you notice this? And people who put very less R, okay, this is a very good observation. I'll tell you one thing. Actually, somebody told me, who are the unsatisfied people in an organization?
Those who work hard.
Exactly. Right. So that's what it is telling you here, isn't it? I didn't intend to. I forgot actually that. And okay, this is what data told you. People who work very hard are the people who are unsatisfied. It's not me telling it. It's the data telling you, right? Right. So, and you can see other people are people who are satisfied hardly work. I mean, yeah. So this is the information that it is telling you. This is the information. This is one bucket. People who work, really compared to others, if they are working very less here, they have.
They don't have work, so maybe less.
Yeah. Right. Pretty much fine. Okay. So this is definitely an important information here that you are getting.
They put the paper and see the other opportunity.
Okay, let's come back. Okay, so let me go ahead. So understood what is scatter graph. Scatter graph is good when you have lesser data, but as you saw here, if it is more data, right, you'll always use hexagonal bin plot. Okay, then in the right hand side you saw this color, this color, this is your intensity information, which takes higher the value density. This is the information we're getting
So
here.
suppose I am having a data from outer side from any software. Can I take that data and compare it with the data generated in this Python or this Jupyter?
Of course. As long as, see, what you can do, if you're using data from any other place, write it in a CSV file, load it from a CSV file, create a pandas object, then you can play around with this. See, I always recommend to use this way of style. If you see older books and notes, right, even for my notes, I used to use this PLT dot, but there you have to write a lot of parameters, which personally I never prefer to write, and it's a hassle unless you really want some way too much fine tuning. Okay, so in the beginning, always what you can do is you can use this library, data frame libraries, series library, then use that. This is the easier way to do it. As you can realize, I mean, this is more R style. In R, the visualization is better than Python. Okay, and now Python is catching up with it a lot. Earlier, if you use libraries directly, right, it was not as good as, it was way better than Python. But now, because of data to visualization, it has become better. Okay, this is not a very older style of doing it. This is pretty new style that you see. So refer to new documents, you'll find this style. You refer older documents, you'll find the older style tactics. Okay, so yeah, so that was about plot. And now another important plot that is required is pie plotting, pie charts. Okay, remember pie chart is not useful if you have to plot a lot of data. Okay, if you have a smaller competitive analysis sort of happening, you can use this.
Like the number of departments present in our
number of people based on the departments and all that.
And how many percentage of people are stay in the particular department.
Right.
This type of information.
Right. So in this case, what you have, so for example, employee data, you have department name, right? Pie, so might be
series dot plot
pie.
The series here. Series is data series. 6.6.
Oh, sorry, I didn't summarize that information, right? We had employee data. One was the count, right? Department wise. This was the stuff. Huh? Oh, I wanted this. Sorry. This is the information. So if we do plot dot pie, yeah, right. This is the distribution that you can see here. Okay, and if you want to say the percentage of it, there is a field here. I think there is a field here which talks about percentage actually. Just a second. auto percentage.
Can we know the Excel file also or only CSV file?
Excel also. PD read Excel. Read Excel. You can see read Excel. Okay, you have all the other fields here. Read JSON.
But we have to import this PG NumPy and Pandas.
Fine, right? Got a hang of it. What is it? What did it do and all that? Suppose you have multiple columns to be plotted, right? DF multiple columns. So what you can do is, I just used. So this is one information. Yeah, if you have multiple columns with respect to some information plotted, so you can plot multiple graphs. Just that you will pass a data frame name. Okay, so you'll write this. Right, so this is one column, and this is so you can combine these two series to create a new data frame, right? This is another column. As you can see, both of them have same columns indexing, right? So what you can do is equal to pd dot data frame. Okay, pass a dictionary. Say first one is hours, right? emp
column, then we can give that name.
Data.
That is not working.
And then count emp count data ept, right? So df, right? So now what you can do is df dot plot dot py
I require either y column or
so
equal to true.
Yeah, a subplot, right? I was writing it. I don't know why it's not showing it. Subplot is equal to true. Subplots is equal to true.
Subplots.
Yeah. You can see here it will show you all the information, right? But you can see here it is kind of overlapping this, right? And you can actually configure the subplot size also, how you want to do it. What are the information? So you can control the figure size. This is not showing up here. Fig size. 8,4. Right, you can see this now. Makes more sense, right? A little bigger. So 16. Right, make it 8. I think that is a decent size, I guess. Yeah. Right, so seeing this, one info, this is count in the left hand side, this is ours. So you can see, you have the sales people are more in count, and hours wise also sales people. Fine, I mean, you can see this
hours wise are same almost,
right? So it is not bothering you much. So I think everybody is putting their efforts. So that's the thing. Got it, right? So this is a simple data analysis that you did on the employee data here. Okay. Now, what you have to do is, suppose you have to find what is the ideal number of projects, right? What is the ideal number of projects somebody should be working in? What will be, if you know, you're the owner, the management of the company comes and asks to the data scientist, okay, tell me what is the ideal number of projects people should be working in? What will be the answer?
We need to understand like the variables or the factors on which we can.
In this case, there is one column, number of projects, a number of projects. So you want to find out
how many people are doing 2 projects and how many people are doing 4 projects.
Yeah, and with respect to people who left.
Yeah,
got it.
That is
Right?
what variables.
So basically, you want the ratio, right? So let's first do for left. Okay, how many people? What is the project distribution of people? I mean, okay, who are there in the organization? Okay, so what you do is employee data projects, right? Group by number project. What is the column after that? After number of project.
Left.
Left. Right. You can see the distribution that. Right. So this is, so here what you want to do, you want to find, this is the total number of people with project 2, right? But you don't know if the left value was 1 or 0, isn't it?
So no, we have to do.
Can we do it the priority basis? It's any priority in the
actually
data set will be there. Priority, yeah. No priority. Also ideal project.
No. What you want is, you basically want to find out how many people. What is the ideal number of projects?
We need to create 2 series. One should be called sum of left, and that should be count. So count will tell total number of people.
Right.
And then the sum is 1 or 0.
Right.
So we will know how many. Then we can compare the percentage of the third column maybe, and then based on the region.
Right. So if I give, okay, for this particular, what will be the what you have to do, you have to find the ratio, isn't it? How many total people are there? Count will be total number of people, and in that, how many left are there? You basically have to divide it, and that will be the column, right? So here, something clicks you with respect to apply. What do you have from this apply? What you have to do is, okay. Right. Okay, apply. What you have to do here, you have this left column here, and if you do the count, it will basically give you a count. It doesn't matter which column you are using it. That part is clear, right?
Yeah.
Okay, like right. You see, the count is giving a total number of count. What I want is in this particular data, in this project, right.
Can we use 2 group by 2 columns?
Group by, you want to do it on multiple columns?
Number project and then
okay. let's first do this apply style, then we'll see that style. So okay, so see, on basis of left you got this apply, you have this data. Okay, print, always do this to see type of D. Okay, you can see how many columns are you getting. 1 2 3 4. I mean, this is basically for each project you are getting this information, right? So what you have to do, you have to find the mean of it actually. Isn't that the answer?
See again, why?
Because you'll either the value will be 0 or 1, right? If you find the mean, it will be sum of all the data divided by number of all the counts. If understood, right? Why mean will be the answer? Return. See this. Remember all the values will be, this is a bit array. That means 0 is 1. If you find the mean of it, it will give you the ratio, right? Got it, right? It will give, because it is 0 and 1. Sum of the data will be that, and if it is all 1, nobody left, then it will be 1 by 1, that is 100%, right? So make sure you understand this, because this line you write in many places, because lot of data is in vector representation, 1 and 0. Okay. Oops. What happened here?
NP is not.
Oh.
Why
I didn't import NP? Right, you can see here this is the mean of this people, this is the mean of this. So what is the, I mean, what is the ideal number of, what is the best number of project here? Remember, it is sum of ones. 0 is people who didn't leave, right? So if all the values are 0, that means that the final value will be 0. So that means the value, this should be closer to 0. The more it is closer to 0, the ideal it is, right? And so what you have to do, you have to plot this graph.
You can multiply by 100 also
to get the percentage. Got it, right? Okay, and this information you can plot it. Okay, so that's why I say this apply. So you're saying, understood, right? This output, is everybody clear with this output?
Ideal number 3.
Yeah, idealist number of projects is 3.
4. Better productivity.
Yeah, he will be a manager very soon. Okay, so yeah, so 3 or 4, but definitely 2 is not ideal. Why 2 is not ideal number of project? Because 2 is there, people have a lot of time, they quit or find better jobs. If they have 7 projects, they surely they will quit the job. Okay, a lot of work to have handled, right? Okay, let's see now. Okay, so what do we have to do? We have to plot this data. Okay. Yeah, I mean, you can, I mean, generally, right, it is, this is, I will store this to a, but this is
series.
Yeah, this is series. Sorry, should I store this as? What should be the name? It is people quitting. People quit. Yeah.
Here F parameter will be what?
Huh?
Apply of F, right? What is F here?
This field, this field F.
Yeah.
This is your function which gets applied. And what is it doing here? Actually, I needn't write this. I can use a lambda, because for each, but just to understand this aspect, that you are calculating lambda x np dot mean x. Okay, so this what is it doing? It is finding mean of all the columns which has suppose number of project 2, people with number of project 2, there are a lot of vectors which is 0 or 1. What are you doing? If you find mean of it, it will give you what is the average behavior. I mean, what is the number of ratio of people who left versus who quit. But this data, whatever you see here, it is not a good way to represent. What would I want is, I would want it reversed, because you want people who didn't quit to be reversed, right? You want this format now. So what you will do is, this is, and sorry, not NP. Right, as dot plot right? So you can see this is the distribution, right? So this is what it's telling you. That means people with 3 number of projects don't quit much. So make sure everybody is around 3 projects. Make sense?
Yeah.
Because whenever you're plotting some information, something is lesser means you don't like it. That's a negative feeling that we get. So always, convert the data into a format which is more intuitive. See, visualization is very important because you have to think from the viewer's perspective, not yours. Because mostly the people who will be viewing it might not have data science background also. They stats. On this thing is this plot. If you plot such thing and it goes viral because a lot of people understand it. Okay, so it's important that you convey the right message.
Sir, how this left was using by group by, sir?
Huh?
What is the application of this left? I can't understand that left. You are using that.
Left is that the person left the organization or not, quit the organization or not. Understood, right?
It's a column.
This is a column name. You're asking about this. This is the column name. Basically, this left values will be 0 or 1. 0 if the person has not quit. 1 if the person. Fine.
Sir, okay, sir.
Okay. So. Yeah, just pick up this. This is very. So, for example, if I ask you, what is the ratio of time spent? This is, I think, weekly time spent. Okay. Promotion. Do you think salary is very important?
Yes.
Do you think salary is very important? To find out the relationship between salary and quitting. Proof.
One of the factor now.
Okay. So what we'll do now? We'll do the same stuff. Yeah. So salary, there are 3 categories: low, medium, high. Okay. So and try to plot this low, medium, high. There are 3 fields here, right? Okay. Group by. Left. Okay, salary. Okay, actually this API is very powerful. Okay, so say example, if you do this group by, can you do this? Okay, I think this is something that comes to many often a lot of people's mind. You have left.
High salary 6% left.
Okay, so you get this information here, right? So you can see here. Okay, this is one way which you're doing. So 0, high, this is the number of count. 0 means people who left having high salaries is this much count. People who didn't leave, sorry. 0 means didn't leave, right? Didn't leave, high salary, this much is count. You can see here multi levels now, right? This is your left, this is your salary, this is this information. Okay, so store this data.
In this case, can I exclude the one part, the one which already left?
Okay, can you use this as series? Okay, so D. Right, so this is how you access multiple indexed data, right? So you can plot that also information. Right, so what
we can also directly do plotting for D0 and for the D0 versus quitting.
No, you can plot. See, you have this data here, right? You do D0, right? You can plot a graph for this.
For D0 versus salary.
Yeah, you can do that. So this is one plot bar. Right. So this is people who are with the company now. Right.
This is the count actually.
Count.
We cannot get the
plot bar. Okay. You're basically getting the count information. Of course, what you can do is you can now find the ratio between them and then plot the ratio. That is the final verdict. Right. But you see the distribution separately like this. Right? Right, you get a distribution here. I can see that this is a people who quit, right? So people with low salaries quit.
So this proves
the
salary less.
Right. But people with high salaries also quit. Maybe they
yes.
are done with that stuff. Right. Okay, got a sense of these things, right? Okay, how do you visualization? Let me run through a few more things quickly. So remember the golden rule of visualization, it should be simple. It should be simple enough. Anybody, I mean, you don't expect the viewer of it from data science background. Okay, so a few things, which these things is not something you use very often. I want to talk about one more tactics. So first thing is, this is another thing that gets used very often, the table plotting. Okay, can you see this? What happened over here? You have a table, right? You have a table like stats information, and you want to plot days information. Like this is one day, this is another day, and so on. So you can see here, this is a row A, days first information. This is the information. This is the data. Days first second information. This is the data. This is table plotting. Okay, this is the table that you want to plot, and this is the data how it gets plotted over here.
Each row. Okay, so this is how you might configure few things, subplots
for different departments, sales for different departments on day 1, 2, 3, 4.
Right.
So you can also do visualization. This, for example, in today, what is the temperature?
So, see this.
If we don't want some data to be showing up here, so we need to make it as a set visible equal to false, right? How you done here?
AX get x-axis you don't want to show anything here. Okay, so this is how you can control the data here actually. So you can see here, you can see the x ticks here, right? And which looks very dirty and unreadable. You don't want to show this information. So okay, with that I will introduce one else. You can see here subplots, right? PLT subplots, and it returns two objects. One is figure object. Figure object is the complete placeholder object. Okay, so this is for little complex plotting. Okay, now you understood all the basic things. Now let's proceed further. This is one step further. That's it. Okay, so when you do this subplotting, okay, fig plt.subplots 1 cross 1. That means you have one area in which you are plotting it 1 cross 1. One information. If you do 6 and by 2, every time it will be image of size 2 inside it. Okay, then what you're doing it fig ax plt.subplots 1 cross 1, and okay, so now onwards, if wherever you try to configure or control it, you can do this with this ax variable.
We have not used fig anywhere.
Right. So earlier, if you don't use these things, it will be left to its default control to do it. So you don't need the control of fig or ax. What is fig? Fig. So in this case, ax will be only one, since there is only one image that gets generated here. Okay, let me just talk a little bit around it. Let's take this guy first. Okay, this means
1 by 1.
Okay, so this is two things here, and in this case, if this is the case, ax will return ax. You see, ax will return two objects. Did you notice this? Figure is opposite of entire thing. Ax is two objects. Now you want to do this. Okay, you want to do something to first image, huh? AX0. Since the held won't appear, so I'll just write A to this. Okay, then you can see X. X. Can you see this? What happened? You mentioned 8 settling 5. Okay, so it actually setted the value from earlier. By default, it is 0 to this, right? Okay, now it is 1 to 5. So this is how you control it actually. Okay, once is you left it to default interpretation, and okay, and if you have to control it, you can do this a dot set xlim, and if you do this set ylim, set y label, for example, you mention the label here. Good. Okay, see this what happened, right? You can see the label that comes up over here, right? Then you can mention set x label. Yeah, I mean, so now that you know, you are controlling it. Earlier it was taking the column name as label, data frame name. I mean, whatever you mention, you do that. So then here you have set, okay, x. Okay, set x ticks also you can do. A. Oops.
Tab is not one.
Set x ticks.
No, nothing is there.
Ticks. Acha, ticks is equal to. Ticks is equal to. So now, okay, if I change it, that you can see here, I mean the range, right, 0 to 99. I mean this is what it will do actually. Because of X limit it is showing.
If you string, then it will mark
that A, B, C and all that. Okay, then it came here 0 to, okay, mark it A.
It says no attribute X.
Right. You can see this X ticks value over here, right? 1, 2, 3, 4, 5 and all that. And similarly Y ticks also you have to show this A dot set ticks. You can control it. Then if you want to set some, you know, text in middle of it, you can write that text A dot set text, text here. Positional, yeah, it needs location actually. Yeah, Y, X and Y 0.5. It needs set text.
Is there already showing? Convert string to float. Oh, it is taking the first argument as x, right? Yeah. Yeah. So here,
And first position S. And 1, 1 it.
Oh, I think
yes.
yes.
S equal to
Yeah. S was a string, right. So that's how these are the positions x and y, right? Based on that, you can plot it anywhere you want. Okay. So if it is previous cases like you're doing PLT dot bar graph, you're doing right subplots. Figure is this, and finally, where is it?
X equal to index, Y equal to column name.
You can control. I mean, if you don't want it to be controlled by that, you can use this guy and control this. Yeah. Okay. But more or less, this is in the till an extreme case you won't be needing this thing. More or less, that is usually fine for 85% to 92% of the work. Okay. Okay. As you can see, it gets lot many arguments. Just have to find which one is for what, and that's pretty much it. Okay, I think we are done with visualization. Okay, so it's not that visualization ends here. Okay, and that data ends here, because whenever we are working on the data part, we'll be continuing, and there are a few more things that we will discuss when I actually use it further. You got understanding of basic foundational aspect. I mean, this is good enough to proceed further. In fact, in data frames also, whatever you understood, that is good enough to proceed further. Okay, and as we do machine learning, we do data processing as a prerequisite to that. And before you actually doing prediction, or after you do the prediction, you need to plot graphs to see what is happening to the data. So we might end up plotting it in a session, sometimes we might not, but the entire process will need it. Okay, so this is pretty much getting the tools ready so that we can get to the next stage.
Mostly we use matplotlib and not the other one.
No, Seqbond is a separate library. Okay, which is based on matplotlib, of course. Okay, so feel free to use it. You just have to set, if you want to set Seqbond here by default library, you can do that. Okay, and I mean, this is the foundational plotting library.
Yeah, that would be great.
For plotting.
Maybe
Pandas and all assignments are there, I think. Pandas. Matplotlib directly no. I mean, as of now, no. What you can do is, I mean, there are data sets available. Okay, so whatever analysis you're doing there, right? I mean, not directly. Whatever analysis, say, take a case. I think we have one here. That's it. But yeah, there will be stat session as well. I think for this batch, it has not happened. Okay, so few of the folks.
Statistics.
Yeah, so all the statistics, Ashish will take that class on the weekend. So what you can do is you can download, this is your sales data. Okay, from this Kaggle you can download this data over here and do some sales data analysis. The link is there in the Pandas assignment section, right? I've added it over here.
State learning and all, it comes in the machine learning.
Right. That is where we'll discuss.
Only state learning, or after that something regression?
No, this is all part of scikit-learn.
Okay, all part.
Scikit-learn.
We'll go one by one, all the theorems.
Right.
Inside this thing.
Okay, let's catch up next week. And next week, if you want, you can read something about what is machine learning and all that. Okay. But anyway, I will be getting started. This is the notebook that I will follow next weekend. Introduction to machine learning, then processing scikit-learn. Fine, right?
We'll do these two only. These two.
Yeah, these 2 next weekend, and after that all the other properties.
Can you just show the link which we are used for my project? Which link?
Yeah, last one visualization using Python.
Okay.
Let me say today's files. I'll upload today's files. Chalo, bye.
Actually, I didn't go through these things. He told us to read that. Visual.
Oh, okay.
I
Go
read
through.
it and send it out.
Sure.
We have some half an hour class.
Absolutely.
For me also same problem, sir. I didn't attend the first 2 classes.
So what you do over the week, we'll try to plan something. Okay.
Okay.
Okay. In the meantime, what you can do is go through